Hello and welcome to the Unit 4 Section 8 video on key features of linear functions. So we have been talking a lot in this unit about linear functions, how to graph them, how to identify slope, how to find the y-intercept, and things like that. We're going to bring everything together and just do a little bit of identification. What makes a linear function? What are the features of those linear functions? So for here, I'm going to need you to refer to this graph as an example as we go throughout, because this is going to be kind of our example as we go through each of these features as to what each thing is. So make sure you have your notes handy, because as I scroll the page down, you will not be able to see that graph. So let's start off with the x-intercept and y-intercept. Well, they are exactly what they say they are. They are where the graph crosses the x and y axis. So in this case, our x-intercept is going to be x equals -5, and our y-intercept is going to be where y equals 2. Now for our slope, that is our rise over run of the graph. So we have done that quite a bit. We're going to take our rise, which is 2, and our run, which is 1, 2, 3, 4, 5, and we're going to write that down as m equals our rise of 2 over our run of 5. So our slope is 2/5. The domain and range. So the domain and range are all possible x and y values, if you recall that. It's always going to be -infinity to +infinity for both the domain and range for a linear function, with one exception, and that is if you have a horizontal line. If you have a horizontal line, your domain is still going to be -infinity to +infinity, but your range is going to be whatever that y value is. So it will be a set of one number, being that y value. So for the graph that you had above, your domain is -infinity to +infinity. Your range is -infinity to +infinity as well. In most cases, this is going to be your domain and range. For increasing and decreasing, if you have positive slope, then your graph is increasing. If you have negative slope, then your graph is decreasing. Well, this graph, and you always, by the way, read it left to right. Okay, so in this graph, our slope is positive, and you can see from left to right that it's increasing. So we have an increasing graph. And then the end behavior. It describes what is happening to a function as x approaches the positive and negative infinity side. So x approaches infinity is going to be the right-hand side. X approaches negative infinity is going to be the left-hand side. So on this graph, as we're going to the right, the graph is pointing upwards. As we're going to the left, it's pointing downwards. So as x approaches infinity, f of x, which is our y, approaches infinity. As x approaches negative infinity, f of x, or y, also goes to negative infinity. So you're going to write it as f of x approaches infinity, and f of x for negative infinity approaches negative infinity. And your f of x infinities are going to flip if it is decreasing instead. So that was specific to this one. Here it's going to be plus or negative infinity, and here it's going to be plus or negative infinity. So for this particular example, as x approaches infinity, f of x approaches infinity. As x approaches negative infinity, f of x approaches negative infinity. Let's do a few examples. So for this first example, our x-intercept is at x equals -2. Our y-intercept is at y equals -7. Our domain is -infinity to +infinity, as is our range. Our slope, well, we have to go down 1, 2, 3, 4, 5, 6, 7. So we've got -7 over 1, 2, run of 2. So -7/2. This graph is decreasing. From left to right, it is going down, and our slope is negative, so that also tells us it's decreasing. As x goes to infinity, so on the right side, f of x is going to -infinity. And as x goes to -infinity, so on the left-hand side, f of x is going to infinity, or our y. Again, f of x is just another way of saying where our y is going. In the next example, our x-intercept is at -2, and our y-intercept is at -4. Our domain is -infinity to +infinity, because we have an arrow on both the left and the right. Our range is -infinity to +infinity because we have an arrow on the bottom and the top. Our slope is -1, 2, 3, 4 over 2. So -4 over 2, which reduces down to -2. Remember, you must always reduce your slope. This graph is decreasing. It is going down, and the slope is negative, so again, that tells us it's decreasing. As x goes to infinity, so we're looking at the right-hand side, f of x is going to -infinity. As x goes to -infinity, f of x is going to infinity because it's pointing up on the left-hand side. And then finally, for this example, our x-intercept is at -2 again. Our y-intercept is at 4. Our domain is -infinity to +infinity because we have an arrow on the left and right. Range is -infinity to +infinity because we have an arrow on the top and bottom. Our slope is going to be 1, 2, 3, 4 over 2, which is going to reduce down to 2. And it is increasing because our slope is positive. As x goes to infinity, f of x also goes to infinity because on the right-hand side it's pointing up. On the left-hand side it's pointing down, so f of x goes to -infinity. So that's basically all there is to identifying key features in linear functions. All right, so that does it for this half of the unit. We will continue on the unit after your next test in section 9.